Okay, now when drawing diagram, a few things that you must pay attention. First, the diagram is functional. Functional means not leaking and properly stopper. Okay, what does this mean? Okay, now when you want to draw a test tube, the mistake, common mistake made by students. Okay. Okay. So this is the reactions here, and it produces gas. Okay, and then the gas is directed to somewhere else by using the glass tube. Okay, this is the cork. Now, so this is considered not functional. Why? Because the tube is blocked. The tube is blocked. So this is not functional, sir. Wrong. Okay. And second, you see here the cork is fully inserted into the test tube. So this is also not correct. Okay. So you must draw the mouth of the test tube, here. Okay. To show that the cork is not fully inserted into the test tube. So it cannot be blocked. And sometimes some students when they draw, okay, this is considered leakage, not acceptable. So make sure that there's no leakage. The glass tube is not blocked. So that's the first things that you need to pay attention. Next is it must be labeled. Now a lot of students ask, what's the apparatus and what's the material that you need to label, and what's the things that you don't need to label. Usually apparatus you don't need to label. Like for example, test tube. Okay. You don't need to label test tube. Why? Because when you look at it, you know it's test tube, then you don't need to label it. Okay. But the material, okay, like for example, what is this? Water or acid or what? Okay, like hydrochloric acid. Okay. Don't use formula. Okay. Don't use HCl, hydrochloric acid. Okay. So then you label it. Okay. So with label. So usually apparatus don't need to label unless the apparatus when you look at it you don't know what it is. Then you need to label. Okay. Like test tube, glass tube, conical flask, round bottom flask, all those things you don't need to label. But if you're not sure, then you label everything. Okay. If you're not sure, then try to label everything. But material usually you need to label. Now when label, try to use straight line. Try to use straight line. Okay. Don't use. Okay. This is hydrochloric acid. Okay. So don't do that. Another thing that you cannot do is use arrow. This is hydrochloric acid. Cannot. Don't use arrow. Don't use a curvy line. Use straight line. And when drawing, actually you don't need to use ruler. Okay, don't need to use ruler. And when drawing also you don't need to use ruler. So don't be artistic. Okay, curvy line like this or an arrow like this. Okay, use straight line. That's all. And don't use formula. Use word, name. Okay, yeah, for the label. In essay questions, if they ask you to describe an experiment, they do not ask you to draw the diagrams. So if you draw the diagrams, usually no mark. No marks will be given to the diagram. But still, if you have enough time, you are still advised to draw the diagram because that can help you to get mark. That's for paper 2 essay. Okay. Again, usually no marks is given. Okay. But if something you draw in the diagram but you forget to write in sentence, okay, mark will be given based on the diagram. For example, okay, let's say you have chemicals here and then you need to heat it. You write heat. Okay. Now, if one of the mark or one of the point is the solution is heated, you're supposed to write in your answer again, the solution is heated. Okay, but you forgot to write this. But in your diagrams, you write heat. Okay, then 1 mark will be given to the diagrams. Paper 3, paper 3. The diagram need to curve down, right? Yeah. But this one just want to tell you about the heat, okay? So you see, even in chemistry, okay, you draw diagram, sometimes the diagrams can help you to get mark. Just sometimes, okay? Not necessarily must have, okay? But if you have times, then you're advised to draw. Involve solution, the solution should be shaded. For examples, okay, if it's a solution, okay, don't write this, okay, this is hydrochloric acid. Okay, not correct. You must give shade to it. Okay, for liquid or solutions, need to be shaded. Okay, label with wrong spelling, minus mark. For specific name like hydrochloric acid, yes, wrong spellings, minus mark. But for common name like acid, it's okay. You write acid, okay. Hydrochloric, cannot. You write hydrochloric, hydro, cannot. Okay? Specific name must be correct. Usually, the teacher do not check your grammar. So grammatical error is okay. Spelling, common words is okay, like acid, okay? Don't write HCl. Don't give formula. Okay, if it involves heating, draw arrow with the word heating below it, okay? So if you want to heat it, you don't need to draw a Bunsen burner, okay? You don't need to draw the Bunsen burner, okay? Retort stand, not retort stands, it's okay, just write heating, okay? Arrow, arrow, heating. That's why you cannot use arrow for your labeling, because arrow has different meaning. Okay, arrow is used for heating, so you shouldn't use arrow for labeling. How about write heat? Okay, it's okay, acceptable. Heat or heating? You're advised to write heating, okay? Write the word heating. How about wire gauge? It depends. Wire gauge, it depends. Some experiments you can use wire gauge. Some experiments you cannot use wire gauge. So for the experiment, you want to find the heating curve. You should use wire gauge. Heating curve. You should use wire gauge. But to find the heat of combustion, then you shouldn't use wire gauge. Sinyi asked, how about you write an arrow and then write heating? Okay, should be acceptable. Okay, should be acceptable. But why you want to do so? You're advised to write below. Okay, but you write beside should be acceptable. So Hui-Cheng asked about the wire gauge. Okay, why in heating curve you use wire gauge, and why in this finding heat of combustion that you shouldn't use wire gauge? Okay, now first of all, you must know, well, what's the functions of the wire gauge. Okay, the functions of the wire gauge is to help you to distribute the heat. You heat here, and then the wire gauge will distribute the heat to the side. If you do so, then you can heat the liquids uniformly. Okay, every part from here, okay, every part at the bottom is heated. That's why you use wire gauge. But if you want to find the heat of combustion, the wire gauge will absorb the heat, okay, and then the wire gauge absorb the heat and then release the heat to the surrounding. Hence, the heat absorbed by the liquid will be less than the expected value. Then you cannot use wire gauge. So you see, some you need to use wire gauge and some you cannot use wire gauge. Okay, draw the electron arrangements for the compound form. Okay. Yeah, okay, this is some things that I would like to clarify with you, okay? For ionic compound, okay, first of all, number of electrons, the number of electrons for all electron shell is correct, okay? And the charges on the ions are indicated. So it means you need to tell the charge. If you want to draw the electrons arrangements, okay, you need to draw the charge, okay? And for covalent compounds, okay, 8 electrons in the outermost shell, and the sharings of the electron is correct. Okay, how many electrons share is correct. Okay, and all the electron shell are shown in the diagram. You must show all. Okay, don't show just the valence electrons. Okay, and the number of the atoms involved is correct. Okay, is correct. Okay. Now, let's say you want to write the ions. Okay, the ion first. Let's go back to this one. Okay, let's say you want to draw the ions. The electrons arrangements of the sodium ions. Sodium ions. Okay. So the electrons arrangement is 2, 8. Okay, so then you write 2 and then 8 electrons. Okay, and then the charge is 1 positive. Okay, now according to the new mark scheme, okay, the sodium you must put in the middles. Okay, without a circle, without a circle. Don't draw this circle. Okay, just the labels in the middles, and you must put it in the middles. Okay, so the sodium, the formula, the symbol of the elements, you must put in the middles without circle. Hui-Chen asked why it cannot be circle, because the circle is used for shell. So just put the symbol in the middles, that's all. Okay, don't circle it, don't put it below. So this for the drawing electrons arrangements. Okay, don't make this mistake again. Draw a graph. Okay, so when drawing graph, draw the graph with axis label and with correct units. Appropriate scale chosen. Okay, now in physics you can use only 1, 2, and 5, right? Or 10, 20, 50, 100, 200, 500, so 0 0.1, 0 0.2, 0 0.5. Okay, in chemistry it's not that strict. Okay, it's not that strict. In certain case you can use the scale other than this. For example, if you measure, if you for rate of reactions, if you measure the temperatures, or you measure the volume in every 30 seconds, then your scale can be in the multiples of 30. Yeah? So then you can have 0, 30, 60, 90, and 120, and something like this, okay, for your time in seconds. But for physics, you can only use 1, 2, and 5, right? But for chemistry, sometimes you are still advised to use this 1, 2, and 5 for the scale, but sometimes you can use scale other than this. Okay, depends on the experiments. But what? Okay, now after you draw this graph, sometimes you're asked to find, let's say you're asked to find the gradients, right? Gradients. Okay, now if you're asked to find gradients, then don't choose any point which is between. Okay, now this is a line. Okay, this is a line. Okay, so don't choose the point which is between the scale. Okay, don't choose a point here. Okay, or any points here. Okay, for you to find the gradients. Why? Because if you choose a point here, then it's very hard for you to estimate, to tell what's the value here. Because 30 to 60, okay, it's very hard to tell. Okay, you can use 30, 60, but don't use the point in between. So if you're asked to find gradients, then you choose this point to this point. Okay, then you have no problem, because straight away you can tell that this point is 120 and this point is 30. Okay, the reason that we want to use 1, 2, and 5 and not other scale is because for other scale it's hard to tell. It's hard to tell what's the value in between. If it's hard to tell, means that this will increase the error. It will increase the error. Okay, so to reduce the error, then you shouldn't use a scale other than 1, 2, and 5. But in chemistry, if you use the scale other than 1, 2, and 5, then don't choose any points in between these two units or these two boxes. Priscilla asked, can I use the first point and the last point? It depends on where is your last point. Okay, if your last point fall on the scale here, fine. Okay, if the last point does not fall on the scale, then you shouldn't use that. Okay, so you must choose the appropriate scale. Okay, appropriate scale, and the shape of the curve must be smooth. Okay, For rate of reactions at certain time, draw the tangents and the triangle on the curve. Can I use different type of scale in graph? Yes. For horizontals, maybe you can use, let's say, 1 cm equals to 2, like a 0, 2, 4, okay? And horizontals, then you want to use 5, 0, 5, 10, 15, okay? Can. For both axes, you can use different scale. And not necessarily you must start from 0. Then you must be very careful because sometimes you need to find the y-intercept. If you need to find the y-intercept, then then the horizontal scale must start from 0. But usually this is for physics, okay? For physics. In chemistry, we seldom ask you to extrapolate the line, the graph, sorry. Same goes with physics. Okay? Not necessarily you must start from 0, but if you need to find the y-intercept, so you must read the questions first, okay? For MX also, okay? You read the questions to see any question that want you to find the y-intercept. If they want you to find the y-intercept, then you must start from 0. If no, then you don't need to start from 0. Okay? Okay, now come to this rate of reactions at certain time. Okay, certain time. Draw the tangents and the triangles on the curve at that particular time. Okay, now what does this mean? What does this mean? Let's say you have a graph. This is a curve. Okay. And then this is 60 seconds. And this is 120 seconds. This is T in seconds. And this is the volume of the gas released in cm cube, let's say. And it starts from 0. Now the first questions they ask you, okay, find the rate. Find the rate of reactions A at 1 minute. Okay. B in the first minute. Okay. Now, at 1 minute, this is a moment. Okay. Exactly at 1 minute. Okay. And we call this instantaneous rate. Okay, that is the rate at an instant, 60 seconds, 1 minute, 60 seconds, right? So exactly at 1 minute, okay. So for instantaneous rate, you need to find the rate of reactions by drawing the tangents. Okay. Still not good enough. Okay, so you draw the tangents, okay? You find the gradients of the tangents by drawing the big triangles. Big triangles. Not necessarily it must be a triangle. It can be something like this, okay? As long as you have the vertical height and the horizontal width, okay? Then you can find your gradients. Then you can find your gradients. Okay, that is for at 1 minute. At 1 minute, so this is an instant. Then how about in the first minute? Now what does it mean by in first minute? Now let's say we have time 0, 1 minute, 2 minutes. Okay, first minutes means that it's from 0 seconds to 1 minute. This is called the first minute. Okay, first minute is a period. That's why you see this is at 1 minute. 1 minute is in first minutes. So first minute is a period. Okay, and for the periods of times, the rate that you find is the average rate. Is the average rate. Okay, so for average rates, then we do not draw the tangents. What we do is, for average rate, what we do is from 0 to 60. Sorry, it should be a straight line. Okay, we draw a line from 0 to 60 seconds. Okay, you find the gradients of it. Okay, you find the gradients between these 2 points. First minute is from 0 to 60 seconds. You must draw a line. Now, first of all, do you know what's the difference between at 1 minute and in the first minute? You need to know what's the difference between an instance and a period. Okay. For example, 0 seconds, 60 seconds, 120 seconds. Okay. So at 0 second, this is one at the instant, or at 60 second, this exactly at 60 second, that's instance. Okay. Now from 0 to 60 second, this is a period. Okay, 0 to 60 second is a period of time. Okay, and 60 to 120 second, this is a period of times. Okay, so period is from a times to another time. That's called a period. But exactly at that time is called an instant. Okay, so that's the difference between instant and periods of time. At the instant of time, and the periods of time. So if they want you to find the rate at 1 minute, means that they only want you to find the rate here at this point only. Okay, the rate at this point only. So the rate of reaction is equal to the gradient, right? So since they want you to find the rate at this time only, so therefore you find the gradient at this time. And the gradient at this time is equal to the gradients of the tangent. So at this point, we draw the tangent. Just 1 point, you see, the line, the orange line here, it just touch 1 point only. You touch 1 point only, and then we find the gradient of this point. For these 2 lines, you should draw a dotted line actually. For this one, yes, it should be dotted line. Okay. Dotted line to the vertical axis 60. Yes, you can use a dotted line here. Okay, but after you draw the dotted line here, okay, still you need to draw the tangents, and the tangent must be as big as possible, because without drawing the tangent you can't find the gradient. Like for example, so this is 60, okay, then you cannot straight away take 60 divided by 60, cannot. Okay, that is not the gradient here. So for instantaneous rate, for a rate at an instance at 1 minute, okay, you find the point here and then draw the tangents. Y divide x cannot. 60 divided by 60, like this case, cannot. And the tangent must be big enough. If you draw a small one, sometimes I know a lot of students actually, they like to draw a small one. Okay, they draw small ones. I don't know why. Okay, just draw. Oh, this is my tangents. Okay, so this is my triangles, and they find the answer from this small triangle. Wrong. Mark will be deducted. Cannot use small triangle. Must be big one, as big as possible. Why? Because the bigger the triangle you draw, the smaller the error that you make. This one, the error will be quite big. If you draw a big one, then the error will be very small. So use a big triangle, not the small triangle. Okay, so that is for instantaneous rate at an instant. But sometimes they would like you to find the rate in a period, like for example in the first minute. Now in the first minute, You see the words that the prepositions that they use is in. Okay, this one is at one moment in the periods. So in the first minutes, now first minutes is from 0 to 1 minute. Okay, let me use 60 seconds. Okay, just don't want to confuse you. This is 60 seconds. Okay, and this is 120 seconds. So from 0 to 60 seconds, this is first minute. Okay. Okay, from 60 to 120, this is second minute. So first minute, second minute, this is a period of time. 0 to 60 seconds is the first minute. Now, for example, what you do in the first, let's say you want to do your revisions, right? What you do in the first hours. Now, first hours means that from the beginnings to 1 hour, right? Let's say you start at 8 o'clock. First hours means from 8 to 9 o'clock. That's the first hours, right? So same goes here, okay? First minutes means 0 to 60 seconds. Second minutes, 60 to 120 seconds. So if they want you to find the rate, usually they won't tell you is average rate, okay? So they want you to find the rate in the first minutes. This is the rate in the period. And rate in the period actually is the average rate. So first minute is from 0 to 60 seconds, right? So then we choose a point at 0 and 60 seconds. Okay? And then you draw a triangle. This one, you don't need to be very big, okay? Just draw these triangles. Of course, if you want to draw a big one, it's also okay. So you draw a triangle connecting these 2 points. Okay, let's say you draw the long or big one, okay? Let's say you draw the big one. Okay, so you draw a big one. Okay, so then you can use this. Okay, for use big triangles. Okay, these big triangles to find your gradient. Okay, so you use this one to find your gradient. Okay, instantaneous rate and average rate. Average rate, we have 2 points. From where you begin and at which point you end. For first minutes, we start from 0 and at 60. So we draw the lines joining these 2 points. That's for average rate for the period. Instantaneous rate, we only have 1 point because we only have 1 instant. 1 instant. So then you draw the tangents. How about second minute? Okay, second minute. Let me erase all this line first, okay? Second minutes, so this is 60 seconds, and let's say this is 120 seconds, okay? So second minute, we start at 60 and end at 120, right? Okay, so we put a point here, 120, 60, okay, and then we draw a line to join these 2 points. Okay? Dotted lines for this big triangle. Okay, and then find the gradients of this big triangle. Must show in the graph. Don't take these 2 points, okay, and then this is your x2, y2. This is your x1, y1. Okay, then you find your gradient. M equals to y2 minus y1 over x2 minus x1. No, don't do this. There's a reason you shouldn't do this, because you do this, the error will be big. If you draw a big triangle, the error will be small. So this is for the graph of rate of reactions. Okay, find the average rate in the first 2 minutes. Okay, first 2 minutes means from 0 to 120. Okay, 0 in 120. So you choose from 0 to 120. So this is your triangle. Okay, so this will be a triangle, and then find the gradient for this one. From 0 it start and it end at 120. So first 2 minutes. Now drawing energy profile diagram. So you must have labels. Energy profile diagram. The very first things that you need to draw is the vertical axis with arrow. Okay. And then label it with energy, the word energy. Without this, no mark. And and then two horizontal lines. So it depends on is exothermic or endothermic. If is exothermic, the energy go down. Okay, so you should have two horizontal lines, and reactants and products are written on the correct lines. So this is your reactants A plus B, and then this is your products C plus D. Okay, and the last one is you must put the delta H. Values of delta H shown. Delta H equals to what? Now, if the values of the delta H is not given, then you just tell delta H is equals to negative. Okay, if it's not given, just say delta H equals to negative. Or you can write delta H equals to negative X. Negative X kilojoule per mole. Okay. So what's important here is you must show that the delta H equals to negative. That's all. Okay. But if it's the value is given, then you put the value here. Okay. So that is for drawing energy profile diagram. Draw the arrangements of particles in solid. Not only in solids, is in liquids. Draw the arrangements of particles with at least 3 rows of 3 atoms each in contact with one another but not overlapping upon one another. What does this mean? Okay, so if they want you to draw the arrangements of particles, okay, so you must draw at least 3 atoms, 3 rows, all in contact. Okay, of course you want to draw more, okay, but this is enough already. Okay, so that is for solids, but cannot overlap. Cannot overlap means that don't draw like this. Okay, cannot overlap. Okay, so that's for solid. That's for solid. Okay, let's talk about gas first. One common mistake that always made by students about drawing the particles in gas is okay, question asks just 3 rows, only at least 3. If you want to draw more, okay, 3 rows, 3 atoms, at least. More is okay, cannot be less. Okay, now for gas, if you draw this, wrong. Okay, or this like this, wrong. Okay, why? Because it shows that the particles are arranged in orderly manner. Cannot. You must show that the particles are random. Random. Okay, so how to show? One here, maybe one here, another one here. Then okay. Okay, you must show that the particles are far away and in random, not arranged in orderly manners like this. So for gas, they are far away and in not in orderly manner. Okay, that's for gas. A lot of students make mistakes on this. They think they just draw a few one. Okay, 1, 2, 3, 4. That's fine. Okay, cannot. It must show the randomness. Okay, for liquid, that is because when you learn in Form 1, I think. Okay, they tell you that solid is like this. Okay, for liquid they are further away, not that far actually, maybe like this. Okay, wrong. Okay, cannot. For liquid first. Okay, for liquid, the atom still in contact. Still in contact. still in contact. Okay, it's not like this. It's not separate like this. First, it's not in orderly manner. It's random. Okay, in contact but arranged not in order, not in orderly manner. Okay, draw the proper circles. Okay, without all this tail. Which asks the atom no need to be in contact with the square. No need. How about draw the circle not the same size? If the difference is not too big, it's okay. Draw them almost the same size, okay? Almost the same size, but not necessarily exactly the same size. So for liquid, don't draw the particles, there is a space between the particles like this. Okay, there are some space like this, okay. Okay, but most of them are still in contact. They're just sliding on each other's. It's not like this. Only gas is separated in this way, but it's further. Okay, gas is separated, but for liquids, they are still in contact. Now this one you don't need to draw it full, because you can draw it this like this is okay, because due to the gravitational pull, the particles will move to the bottoms here. Okay, accumulates here. All in contact for solid and liquids.